Algebra 2, Common Core, Unit 7, Section 6, Average Rate of Change. So the average rate of change formula is something you learned in Algebra 1, so this is another review video. And it really is nothing more than the slope formula that you did a good amount of last year in geometry, so you should be very familiar with it, y2 minus y1 over x2 minus x1. But last year when we did slope, it was just between 2 points that were on the same line. What we're going to see here is that we can do the average rate of change for things like quadratics and really any type of graph. You could do it on a sine curve. You could do it on a cubic function, absolute value, exponential, whatever. And so we know that on curves like a exponential or something like that, where the graph changes like this, it's a curve because the slope is constantly changing. So the slope between like these 2 points is different than the slope between these 2 points. But if I want to know from here to here, what is the average rate of change? How is the graph changing on an average over that interval? That would be just simply the slope between those 2 points. And so that's what average rate of change is. So again, just remember, essentially, it's just the slope formula. But you're going to see questions like, over the interval. So we don't give you the coordinates, we give you the interval, which is your x1 and x2, or your the f of -1, f of 3. These are the x values that we need to find the y values that go with them. A lot of time you see questions on this where they'll give multiple graphs, or one as a graph, one as a table, one as an equation, and say, compare the average rate of change over this interval, and you need to be able to do that. From a table, it's easy, you see the coordinates, and from a graph, it's easy, you see the coordinates. It's from the equation that, like we see here in number 19, that you have to do a little bit of work. So to find the average rate of change over this interval, I need to figure out what is f of -1, and that's simply replacing all my x values with -1. This is, simple function evaluation. Now, I know I could use a calculator for this, but if this is a Regents question, we're probably going to want to see the work here. So let me pretend I don't have access to a calculator and do this manually. So this would be -1 squared is 1 times 3 is just 3. And then -12 times -1 is 12, and plus 17. So we end up with 3 plus 12 plus 17. Let's see, it's 15 plus 17 is going to end up being 32. So in the end, that would give me the coordinate -1, 32. When I plug in a 1, I get a 32. All right, now let me check it out for f of 3. And again, I'm going to replace all my x's with 3's here. So 3 times 3 squared minus 12 times 3 plus 17. So 3 squared is 9, times 3 is 27, minus 12 times 3, 36, plus 17. Let's see, so 27 minus 36, that would be 37, would be 10 away. It's one less than that, so that is -9 plus 7. Take a 9 away from that, I think we're going to get an 8 here. And hopefully I'm doing the math in my head correctly. But that'll be the values of 3/8. And again, of course, I could check this in the calculator, and I probably should, honestly. So let me type that in there. Because, on a Regents, even if I want to show the work, I can at least check my answers in the calculator, which is certainly a smart thing to do. So let me just pull this up. Just take a second. And once we have these two coordinates, and once we've confirmed these are points on this graph, so let me type in now 3x squared minus 12x plus 17, and I go to I don't need to even look at the graph, I just really want the table here. And I want to know, is the point -1, 32 there? Yes, it is. And how about 3/8? Yes, it is. Okay, so I've confirmed my math here was correct, and that's always what we want to do in mathematics. We want to, be careful with our algebra, but we always want to, make sure that we are confident in our answers. Do they make sense? Are they accurate? All right, so now plugging into our slope formula, or plugging into this formula again, remember that f of x is y, so f of x2 is the y value paired with x2, and f of x1 is the y value paired with f of 1. And we do like to do second minus first, which is right minus left. So on a graph, you could easily tell that. Sorry, wrong way. For these 2 points, I could tell that this would be the point further to the right because, well, it's got the when we list an interval, we list them, left to right, least to greatest. So this would be, my x2, and so then this would be my, y2 or f of x2, and this is my x1. But you could also just look at the x values here and see that -1 is to the left and of +3, which would be to the right. So I want to do the right points, the second points, that would be these. And the y values on top were the f of 3, which is 8, 8 minus 32 over 3 minus -1. Let's remember, these go together, this was a point, and these go together, this was a point. But we do the second minus the first. And 8 minus 32 is -24. And 3 minus -1 is +4 when we subtract the negative. And then we divide this, we get -6. And so there's your average rate of change. Like I said, from a table, then you just take the points, and from a graph, I just look at the coordinates, and from an equation, I have to figure out the y values that go with these two input values. But this is really just slope formula. It's something simple, but it's something that's really important, and it's going to become really even more important as you go further in mathematics and get into calculus. This rate of change of a graph, it has to do with the derivatives and things like that. So it has a lot of value going forward. So hopefully you can get a strong grasp of it now. All right, so that's it. Nice and short video today, and see you later.